Hey, Algebra 1. So today we're going to be going over that review page from Thursday. And your assignment today is going to be to correct your paper from the other day. So there was a lot of good stuff, and then there was a lot of tricks that you didn't catch on to. And I mean, that's to be expected because we're not in close proximity. And, you know, it's a different learning environment. And so that's totally okay. But I think what we really need right now, especially since we're still learning new things, is to review and go over as a group what, well, I say as a group, go over all of the problems that we had. So this is one of, I think, 4 videos. I'm going to chunk them into problems 1 through 4, 5 through 8, what was that, 9 to 12, and 13 to 16. So you can identify where you had issues and then double check those. Hopefully that double speed feature is still around, because I know with my college classes I use that a lot, the double speed feature. So whatever your pace is, that's fine. And here we go. So number 1 is a difference of squares problems, and we know that because 25 is a perfect square, x squared is a perfect square, there's a subtraction sign here, and 121 is a perfect square. So this is difference of squares. Another thing that could have really clued us in, sorry, I can't type and talk. Another thing that really could have clued us into that being a difference of squares is that there's only 2 terms here. Now, I know later on we're going to see some more 2-term things like this one down here. This is not a difference of squares, but that is definitely one of the first things that we want to consider when we see a 2-termed problem. So there we go. There's that. And let's see if my equation editor is still up. There it is. Okay. So obviously with a difference of squares, we take the square root of the first number, which is 5, and then the square root of x squared, which is x. We add the square root of the second term, and then we do the same thing, except we put a subtraction sign in there. Ta-da. Okay, excellent. This one I think most people had the hang of, so that's okay. This next one is a GCF problem. So this is where we're factoring out the greatest common factor. So the first thing that we see here is that there's not, like in this one, there's not just an x term or an x squared term, an x term, and a constant term. And even if we factored something out of this, that wouldn't be where we are. So the first thing we're going to do is the GCF and see if there's anything else to be done. So this is GCF, greatest common factor. And here I did not make an equation editor. There we go. So the biggest number that goes into 10, 5, and 100 is 5. The smallest exponent on the x terms, or on the x's, is 5, 2, or nothing. Oh, nothing, that means 1. So 5x, and then y squared, y, or y cubed. Well, the least amount of y's anywhere out there is just the 1. So that is my GCF. And so I'm going to divide each of these terms by this. So 10 divided by 5 is 2. X to the 5th divided by x is x to the 4th. Y squared divided by y is just y. Minus, because that's the sign that's there. 5 divided by 5 is 1. X squared divided by x is x. And y divided by y is just 1. So there's nothing else to put there. And then plus 100 divided by 5 is 20. X divided by x cancels out. Y cubed divided by y is y squared. See? My good gracious. There we go. All right. So this is it. Now let's see if there's anything else that we can do with this. Well, that's got an x and a y, so factoring trinomial is out. There's nothing left because we took out the GCF already. This is done. Okay. This next one, first thing I notice about this is that all 3 of these terms have even number coefficients. So I know that I can take out a GCF. Okay. And then from there, it looks like it's in trinomial form. So let's pause on that, and then we'll come back and see what kind of trinomial we're going to have to work with here. So 14 divided by 2, because we said that 2 is the GCF here, is going to be 7, and then x squared, minus the 32 divided by 2 is 16. Don't forget the x. And then plus 18 divided by, no, what did I do here? There we go. Okay, so 18 divided by 2 is 9, and yep, I turned off my number lock. All right, guys, I promise these next couple videos, they will go faster because we won't have all of this stupid crap going on. There we go. All right, so there's that. So this is going to be either Xbox or grouping method, whichever one makes you happy. And I saw a lot of people who liked the grouping method on our survey, and that's totally okay. A lot of people like the Xbox too. Here I'm going to type out the grouping method because it's really hard to make a box. So there's that. Now on your paper, you can do whatever makes you happy there. And it's all pretty much the same thing. It's just in a different format. So we're going to leave the 2 out front for our final answer. So I'm actually going to make this line here for our final answer. So we are going to look at this. We need 2 numbers that multiply to be a times c. So multiply to be 63, which is 7 times 9. And then they add to negative 16. And those numbers are going to be negative 7 and negative 9. I guess that fits here and there. Okay. So whenever I write this out as the grouping method, remember it's the first term, so 7, I need my equation, 7x squared minus 7x minus, okay, so I'm having a hard time with keeping my number lock here. Minus 7x minus 9x, and then plus 9. And so I'm going to group that as right here. And then I'm going to put my plus in, and I'm going to make my other group. Guys, can you tell? It's just not my day. Not my day at all. This keyboard's not working with me. All right, so those are my groups. And what's nice is out of this first group, the 7x comes out, and that leaves me with x minus 1. And remember, in this, the, what's it called? The stuff inside the parentheses on each one of these groupings has to be the same. And then since this first term is a negative, we're going to factor out the negative. And so we're going to subtract or take out the negative 9. And then we will have x minus 1. And the reason that this is going to be x minus 1, even though there's a plus sign here, is because 9 divided by negative 9 is negative 1. All right, so my 2 terms are going to be, see it twice, write it once, x minus 1. And then the other one, if I slash that out, I'm left with 7x minus 9. And you see how that 2 stayed out in front. That's because that's the GCF from the very beginning. All right, let me see what kind of time we're on here, because I feel like I've been talking forever. Ugh, okay, alrighty. All right, so last one in this series, or in this section. This one is almost exactly the same as this one up here. So it's very, very similar. First, there's a GCF, and then we are going to, oh wait, I'm sorry, no, there's not a GCF, my bad. But we are going to see that this is almost precisely like this set right in here. And so this is an Xbox grouping problem. All right. So what 2 numbers multiply to be positive 10 and add to negative 7? And so those numbers, of course, are -5 and -2. So here, there it is. We're going to see 2x squared minus 5x. Sorry, no, let's not do that. Let's put the 2 first because then it looks just like this up here, right? And then minus 5x and add 5 at the end. Okay. So that does look almost exactly like this right here, except instead of 7s and 9s, it's 2s and 5s. All of the signs are the same and everything. So we're going to group this again, and we're going to put our plus sign and group the other half. There we go. And then we're going to see that out of that first set, 2x is the greatest common factor, and we get x minus 1. It's the exact same. And then -5x and 5, a 5 comes out specifically in -5 because that lead term is negative. And then we're left again with x minus 1. And so see it twice, write it once, and we get x minus 1 and slash them 2x minus 5. And so this is our final answer here. All right, guys, I promise the next videos will go faster because I don't have to introduce anything, and I'm just going to pick it up and go. We'll see you in just a second. Bye-bye.